right, so you did this through. There are our numbers. We need to add them up. What were your number of wins for the group? You had 8, 4, 5, 2, 6, 1. There was a little bit of variation, right? Based on the results from your group, what was the probability of winning this game? So, out of the 10 times you played, how many did you win? Okay, so like if you got 4 wins, that's 40%. Yes? Everybody okay? All right. So on your paper, whatever your number of wins is, you're going to take that and divide it by 10. And that is your percent or probability of winning this game. Everybody good? And it's going to vary from person to person. Okay. All right. Now let's see what happened in other groups. We already recorded up at the front. Number of wins for the class. So help me, help you, help us. Everybody add those numbers up. Okay. We all got to get the same number. So take them on your paper. You're going to put 112. Based on the results from the whole class, what is the probability of winning this game? So really quick, we take 112 and we divide it by how many times was this game played? So I see some of you counting. So you're counting how many numbers there are. Counting how many numbers there are. Tell me how much that is. 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There are 21 people in here. How are there 23 numbers? Okay, try it again. Count again. I don't trust y'all. Do it again. Y'all let me down with the Jen Miller and what was his name? John Miller. Let me down. There's 23 on the board. You got what? You got 23. Okay, we're gonna go with it. We're gonna go with it. Can I not count? I don't know, man. All right. So out of the 230, pretty good. So we did 112 divided by 230. And what does that give me? Okay. Say again. So there's 23 people. And each person played 10 times, right? So that's 230 times that the game was played. And we had 112 wins. Good. Okay, so we're at 0.486. We're going to round that to 49%. Good. Now, my question to you, how could we improve this estimate of probability of winning? What could we do? We talked about it yesterday. More rounds. That's called, in math terms, the law of large numbers. So if we play more rounds, okay, the more we play, the more true depiction it's going to be, right? Everybody got the treasure box? Okay, open. If I get one more. Don't leave me with the Starburst. No. Share the love. Okay. All right, you ready? So, what we're going to do is we are going to complete this table to list out all possible pairs. Do you remember like Punnett squares back in like bio? Yeah, that's what this essentially is, right? Okay. So, how many reds do we have in our bag? How many reds? 4. So we have 4 R's and 2 yellows. And we're going to do that on this side and this side. 4. Okay, so now what you're going to do is a Punnett square. You're going to take this R and put it inside here. R. This R, this R. All right, take a second, fill that in. Why is this box so tiny? What had happened was, oop, on the bottom ones, the left one is the first candy, the top one is the second candy. So this is your first pull, second pull. Okay. Still filling all those in. Remember, first candy pull, second candy pull. So it's all possible outcomes. Yeah. Come in. Hey, what's up? Good morning. Yes. Yep. Go for it. Okay, so the last ones, oop, I messed up on these. You filling them in, or are you just watching me write things? Okay. Okay. So we're going to circle the outcomes with both reds. Okay, we're going to circle the outcomes with both reds. So that's everything that's in here, 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 here. That's all going to give us red, right? That's a win. Yes? Okay. Now, what is the probability of winning the two reds? What's the probability of winning two reds? 16. Out of how many? 36. Okay, so 16 out of 36, which is what? 1/6, which is 16 divided by 36. 16 divided by 36. 24. Okay, so that's 44%, right? Okay, you ready? Throw back to geometry whenever you took it. Okay, yep, it's coming back. So that's the probability of the first red and the second red. Okay, which means that how many reds do we have in our little cup? 4 out of how many total starbursts? Okay, and for the second one, we had 4 out of 6, right? When we multiply those together, we're going to get 16 out of 36. Do you remember this from geometry? There was a unit on probability back in the day. Ooh, stop. Okay. Okay, on the next one, it says, what is the probability of winning with 2 yellows? Let's look at that. So when we do this, 2 yellows, we've got this guy, this guy, this guy, this guy. How many is that? 4 out of how many? Okay, so what probability is that? It's what? Yep, 0.11 or 11%, right? Or 11.1%. Now again, if we have the probability of winning the first yellow and the second yellow, then that's 2 out of 6 times 2 out of 6. When we multiply that across, that gives us that 4 out of 36. Okay. Are we okay so far? Not too shabby. Again, it's kind of like a review from that geometry probability section. So how many yellows do we have in our little cup? And how many things do we have in total in the cup? 6. So 2 out of the 6. Yep. Good. All right. Say again. 4 over 36. I'm just going to make a note. If you have 2 things, I always put the word and is associated with multiplication. Yeah. A little later on, we're going to find out that or means to add. I would make a note of that. So and means multiplication. Or means add. That'll help you a little bit. Okay. The word and. So if I had both red, that would be the first red and the second red. That's why it's getting multiplication, right? All right. On the last one, it says overall, what is the probability of winning? So we're going to look at, I'm going to put that up here. Sorry, it's out of order. This is part C. Okay. What's the probability of winning? Well, what did we have for the red? 16 out of 36. And what did we have for the yellow? 4 out of 36. We're going to add those together because it's the probability of winning red or the probability of winning yellow, of win red or win yellow. Yes. So it's 20 out of 36, right? And what is that going to be as a percentage? 55%. So you have a 55% chance of winning. Not bad odds. Not great. Are you okay on that? Now, a little bit of vocab. This is what we call the sample space. This is what we call the sample space. So all the little outcomes. Okay. Sample space is all the outcomes. Okay. Not too shabby. All right. Once you're done, flip over to the back. I'm going to hit you with some notation that I think you'll kind of remember. Everybody good? I flip. Yeah. Okay. All right. So, some quick note. We just talked about sample space. We talked about sample space, and that's the list of outcomes, list of all outcomes. Okay. So the probability of the event is the number of outcomes of the event divided by total outcomes and the sample space. Okay, so the sample space is the list of all outcomes. The probability of the event happening is the number of outcomes in the event divided by the total outcomes in the sample space. And that's exactly what we did on the last 3 problems. We said, hey, we want to find the probability of winning red out of the total possible outcomes. Yes. E is the event. So if I say winning red, that is the event. Does that make sense? Okay. Now, note on here that all outcomes must be equally likely. Okay, and what I mean by that is, you know how you replaced your starburst? Okay, equal outcome every single time. Okay, if you're like looking at what you're picking, that's not equal. Yeah. All right. The real important stuff I think. Okay, so rules and notation. All right. Let's do this. Probability of A and B can be represented by this notation. Don't freak out. A intersection of B. Okay, so refresher from geometry. This guy means intersection. This guy means union. This is just how we mathly say and or. Okay. Now, this is when both things occur. Both occur. Everybody okay on that one? I'll give you a second to catch up. So, all right, now, if you have something that looks like this, where it says the probability of event A or B, then you have the probability of A union of B. Okay? So, the way I think of this is if I say union, what's the one thing that you think of? Together. So like marriage, the union of two people. Yes. So event A or B happening, that could be like I'm talking to the one partner or the other partner. Does that make sense? And it's equally likely. Yes, that combined power. Yeah. Okay. Intersection, it sounds like, where two roads meet. It's where both of them occur. Yes. Okay. Again, and means to multiply or means to add. Okay. All right. So one or the other occur. I'm hesitant to say this, or both, but we're going to come back to this. We're going to talk about that because that changes a little bit when we start talking about independent events and that kind of stuff. So on the last problem, the previous page, winning red or winning yellow, right? What if the problem said winning red or winning yellow or losing? Now that would be silly because that would be everything combined. But you could make some stipulations if we had more starbursts, different colors. Yeah. We'll see an example of that one in a little bit. Okay. All right. So the last part of this is the complement. Okay. You did talk about this in geometry. Complement rule. I'm actually going to write this over here so you can actually see it. Okay, so the complement rule. And that's probability of A raised to the C power. Okay. So we call that A naught. Okay. So that's also found as taking 1 minus the probability of A happening. And so this is known as the probability of an event not happening. I always read this as the probability of a sight, like literally not. Yes. It's the opposite of whatever probability of A is. Okay. Complement of A. Good. Questions? Okay, let's try a couple. Go ahead and do A through E. And then we shall chat about it. Okay. All right. Take a moment. You're working on that. Yeah. So we've got Pew Research Center reported that family size is shrinking. Suppose we are how many of y'all want to have kids? Sorry, that's such a personal question. Okay. Yeah. Okay. So back in the day, if you asked that question, everybody raised their hand. Like literally. Like people are like, I don't want to pay for somebody else's life. Anyways, I get it. Okay. So here's the probability model. For A, Stephen argues that the probability of a mother having exactly 2 children is 1/4 because there are 4 categories. Why is this incorrect? Go ahead. Okay, so each of these outcomes are not equally likely to occur. Okay, each of the outcomes are not equally likely to occur. You cannot see what's on my screen. Great. Okay. There you go. Okay. Find the probability of a mother having exactly 2 children. Okay, so how do we figure out what this little question mark is? Remember, the total should be 100%. All right, so we're going to subtract all these other ones. I mean, either way, it don't matter. And I got 0.41. Okay. And like, what do people normally do? They find a house or they get married, they find a house, they have 2 kids, and it's a boy and a girl, right? That's the story, right? Okay. No. It says find the probability that a randomly selected mother has less than 2 children. So what are they actually asking you for? Probability of finding what? 1 child. Okay. And what was that on the little chart? 0.22 or 22%. Okay. Find the probability that a randomly selected mother has 1 or 2 children. Okay, so here it is. This is where we start using the notation. 1 child or 2 children. Okay, so that's P of 1 union of 2. Okay, so that's 0.22 plus 0.41, and that gives me what? Okay. So you're looking for this word or to tell you whether or not you're adding or multiplying. Good. Okay, they're gonna try to hide that word. Yes, they're probably going to try to ask it, not probably, most likely, they are going to try to use that word like hidden inside. Okay, yes. You have to show what that means. Are you saying like not writing the 0.22 plus 0.41? No, you need to show that. Yep. What are you adding together? Yep. Okay. On part E, it says find the probability that a randomly selected mother does not have 4 or more children. I cannot talk today. So, probability of not having 4 or more children. Okay. This is also known as P of 4 plus children. Not. Oh, I'm sorry. It should be inside. Okay. The complement of it. Good. So that's going to be 1 minus, what's the probability of having 4 or more children? 0.13. So that's going to give me 0.87. Questions? Comments? Okay. So some people believe that the ability to taco tongue, and what that is where your tongue rolls and makes a taco. Right? And evil eyebrow. That's where like one of your eyebrows like goes up. I don't know if I can do it actually. Like, I don't know. Try it out. Look at your neighbor. See if you can evil eyebrow. Can you evil eyebrow? I don't feel like my eyebrows actually went. Yeah, what you got? Let me see it. Ah! So I feel like there's a lot of variability in this too, because it's like, is my eyebrow actually raised enough to like be evil eyebrow? How many of y'all can evil eyebrow? Oh yeah, Shine's got it. Sorry, I saw it. Can you demonstrate? Do it. Go ahead. Do it. Evil eyebrow. Oh no. Ah, there it is. Okay. So how many of y'all can taco tongue? How many of y'all can do both? Okay, y'all special people. Okay, so what we're gonna do is we're gonna collect the data for the class. Okay. Okay. So really quick, let's see if we can do this. And you got to be honest. Like if you can't taco tongue, no judgment. Maybe a little. Okay. Raise your hand if you can evil eyebrow and taco tongue. So you got to be able to do both. Okay. How many we got? 1, 2, 3, 4. 4 people. Okay. How many of you can taco tongue but cannot evil eyebrow? Okay, so how many of you can taco? I need y'all to pay attention because otherwise you skew my data. How many of you can taco tongue but you cannot evil eyebrow? So just one, two people. Okay. How many of y'all can evil eyebrow but you cannot taco tongue? Raise your hand. Okay, 1, 2, 3. How many of y'all cannot do both? 1, 2, 3, 4, 5. Some of y'all did not raise your hand. You're telling me that I have 14 people in this class? So we'll do it again. I need you to pay attention. I need you to pay attention. Okay. It skews our data when you don't answer. Yes? Okay. So do you want me to use my data, my backup data, or you want to use your actual class data? Okay. So let's try it one more time. There are at least 23 people in there. Ready? So how many of y'all can evil eyebrow and taco tongue? Raise your hand. Oh, okay. More people. 1, 2. Raise your hand. Raise your hand. Keep it up. Evil eyebrow and taco tongue. You have to be able to do both. 1, 2, 3, 4, 5, 6, 7. Everybody good? All right, put your hands down. How many of you can taco tongue but no evil eyebrow? So you can't do the all eye thing, but you can hold your tongue. 1, 2, 3. Good? All right. How many of you can evil eyebrow but not taco tongue? 1. So 3. And then how many of you can't do either? 1, 2, 3, 4, 5, 6. So we're at 19. 4 of you still are terrible people. 4 of you. All right, we're running with it. Okay, so how many do we have in total? 19. Okay, so really quick, we're going to add up the rows and columns. So 7 plus 3 is what? 10. Okay, 7 plus 3, 10. And then 3 plus 6 is 9. 3 plus 6 is 9. Okay, yeah. No, go to the bottom. Okay. All right. So now we're going to put this in the Venn diagram. Okay. So we had 7 who could do both. That's going to go in the middle. We had how many could yes taco tongue, but not evil eyebrow? Yes taco tongue, but not evil eyebrow. That was 3. Okay. How many could yes evil eyebrow, but no taco tongue? And how many can't do either? Okay. We okay on Venn diagram. All right. So suppose we randomly choose a student from the class, find the probabilities as fractions. Okay, so we're going to leave them in fraction form. Okay, so what is the probability of taco tongue? That means that A can do taco tongue. 10 out of 19. Okay. How many could do evil eyebrow out of, okay? How many could not taco tongue? 9 out of 19. How many could not do evil eyebrow? Seeing some similarities. The Jen Miller, John Miller thing is happening again. I got a 50-50 split. They're not real people. Right. No. Oh, no. All right, we okay? Okay, so now we're gonna figure out taco tongue and evil eyebrow. Taco tongue and evil eyebrow. Okay, so hopefully you have that on your paper and you're gonna have to help me out because I don't have those numbers anymore. How many can taco tongue and evil eyebrow? 7 out of 19. Okay, so taco tongue and evil eyebrow is 7 out of 19. And how many can evil eyebrow and no taco tongue? Evil eyebrow and no taco tongue. That would have been 3 out of the 19. Okay. Okay. We good on those. Can you fill in the next two? So yes, taco tongue and no evil eyebrow, and no taco tongue and no evil eyebrow. I'm gonna take a screenshot of it so we can use it. Okay. So what'd you get for yes, taco tongue and no evil eyebrow? 3 out of 19. And then no taco tongue and no evil eyebrow. Okay, so everybody's good. They can read a two-way table. Okay, two-way table is what was up at the top. That two-way table that we filled in, that's called a two-way table. Two-way table. Yeah. All right. But suppose that we randomly choose a student from class, find the probabilities of fractions. So, yes, evil eyebrow. Okay. How many people in the class could evil eyebrow? 10 out of 19. Okay. How many people in the class could no evil eyebrow? 9 out of 19. Okay. How many could yes, evil eyebrow or no evil eyebrow? What did you say? 1. Yes, they could evil eyebrow. Or no, they could evil eyebrow. 19 out of 19. Okay. Okay. Why is it 19 out of 19? Because either you can evil eyebrow or you can't evil eyebrow. That includes everybody in this classroom. Yep. Yes. Say it. Yes. These are what we're going to call mutually exclusive. Mutually exclusive. These two out right here. So they cannot occur together. You can either evil eyebrow or you cannot evil eyebrow. Those can't occur together. Okay, you can't be like halfway, right? Like, yeah. But you can get like one eyebrow, but you can't get the other one. All right, looking at the next part, it says find the probability of yes taco tongue. What about yes evil eyebrow? What about yes taco tongue or yes evil eyebrow? Okay, so you are going to put them together, but what do you have to account for? The overlap. Okay, so how many were yes taco tongue? 10 out of 19. How many were yes evil eyebrow? 10 out of 19. And we're going to subtract that crossover. So look back at your table, and where is there a yes taco tongue and yes evil eyebrow? 7. So we're going to subtract that 7 out of 19. Everybody see it? Okay. So what's 10 plus 10 minus 7? 13 out of 19. Okay. So what we did again was we said we've got to do the probability of A or B, but we're going to find the probability of A plus the probability of B minus the intersection of A and B. I'm gonna give you a second. That's a lot of. We talked about these being mutually exclusive. These are not mutually exclusive. Okay. So for instance, you could taco tongue and evil eyebrow, or you could not taco tongue, evil eyebrow. Or so there's people who can do both. Y'all doing too much. Too much. Okay, flip the page. Okay. Okay. Notes. All right, quick notes. Ready? So we talked about two-way tables. This is gonna look a little funky. That's okay. You'll be fine. These A's and B's are representing events that are happening. So we've got A and B, and we've got B not, and we got A not. And then we're gonna fill in the table, and that's gonna give us this probability, this probability, this probability, that probability. Not. It's a complement. Okay. We talked about drawing a diagram or a Venn diagram of this, and basically it's just a different way to write out this two-way table. So you got two circles, you got event A and you got event B, and that's probability goes here, 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 and anything that's not goes on the outside. Okay, we talked about the addition rule. Just talked about the addition rule. So that means that we took probability of A or B, and we did that by taking A plus B minus the intersection of A and B. Okay, and I do want to note that if events A and B are mutually exclusive, if they are mutually exclusive, they cannot occur together. So the probability of A and B would be 0. Mutually exclusive? Can you taco tongue and not taco tongue? Mhm. So they can't occur together, so the probability is going to be so the probability of A or the probability of B is the probability of A plus the probability of B. Yeah. On your formula sheet, you are given this addition rule. You're given that. But it's in that notation. It's that first one. And it's using union and intersection. Okay? So you are given that formula. Okay. Can we try a couple problems, please? Okay. I will say, Miss old JB. Okay. So the first thing you got to do with two-way tables is what? Add them up. Okay, so a random sample of high school students was surveyed regarding their procrastination habits. All of you. The two-way table displays the results. Suppose we choose a member of the sample at random. Define X as being yes to take the AP exam and Y yes to procrastinating often. Okay, so when you label these, and this is where a lot of people make mistakes on the AP exam, they don't define their variables given the ones that they've told you to use. So X is yes to an AP class. So this is at what's up? Oh, y'all are keeping me on track. Okay. Procrastinating often, that's going to be Y. Okay. All right. So explain in plain language what P of Y not means and find the probability. Again, first thing you want to do is add these columns and rows up. So you should have gotten that. Okay. Everybody okay on those? Okay. So what does it mean for P of Y not? What does that mean? Probability that the student selected does not procrastinate. Remember Y? Y is procrastination, yes? Okay, so the probability that the student selected does not take, I'm sorry, does not procrastinate often. Procrastinate often. Now, how much is that? 34 out of 116. And that's going to be 0.293. All right, explain why P of X or Y does not equal P of X plus P of Y. Okay, so the events taking an AP and yes to procrastinating are not mutually exclusive. Are not mutually exclusive. Okay, so just like what y'all said, it's got to account for that crossover. So you're going to have 70 out of the 116 plus 82 out of the 116, and then you're going to minus 58 over 116. And that should give me 0.81. I'm so sorry, that's at the bottom. Okay, since majority of you did not get past A and B, can you take a moment and can you fill in the Venn diagram? You're using the numbers that are in the two-way table to fill in the Venn diagram. Okay? Take 2 seconds. Look at my awesome circle of doom. Okay, so I got 12, 58, 24, and 22. Yeah? Questions, comments, concerns? Okay. Write the event. Write the event, does not procrastinate often, and is taking an AP class in symbolic form. So, and find the probability. So we're gonna say probability of what is the variable that we're using to represent procrastination? Y. Okay, so does not, so that means we're gonna use that little complement, and is taking an AP class. So yes to AP. Okay. How many people are doing that? Not procrastinating, but yes, taking an AP. 12 out of the 116. And so that gives me 0.103. So much easier than last unit, right? I'm just enjoying the starburst. This is a dark circle. Yeah. Sampling methods. It was just worse. It was like a big vocab, just like 10. We're gonna go back and like revisit that. Okay, so yeah, go ahead.
Here, write out. You said we have to write out.
So well, this is from a two-way table. This is from a two-way table. So like look at your table and it's where they're crossing over. So there's not, you're having 0.22 plus something else. Or I'm sorry, times something else. Does that make sense? So since it's coming from a table, you're not multiplying things together. Yeah? Okay. All right. So what I've done is I gave you a recommended assignment. I also gave you examples and videos. That's an option. You don't have to necessarily do them, but the recommended assignment, yes, you do. Okay? You do need to do the recommended assignment. You can get 5.1 done, and I think you can do a little bit of 5.2. Okay? So if you want to go ahead and start on that right now, you got a good little bit to work on it. Okay?